Hello, this is Professor Brown Cedarburg, and we're going to talk about primitive variables in Java. First, let's define them. A primitive variable in Java is a primitive value that can change during the execution of the program. We recall that primitives are booleans, chars, bytes, shorts, ints, longs, floats, and doubles. So a primitive variable in Java is a variable that can change through user input or by the operation of the program. It might not change at all. When we work with primitive variables in Java, we work with declaration and assignment. Declaration is the setting aside of sufficient storage space to hold a variable of a specific type. Java is a strongly typed language. I must specify the type of my variable. Upon specification of that type, sufficient size memory will be put aside to store that variable. That space will be given a name that we'll use as an alias to refer to that space. Now, having declared our variables, we can now assign a value to them. We assign a value to that variable through the use of the assignment operator, which is the equal sign. So on declaration, I signify my intent to have a variable of a specified type. Storage space in bytes is put aside in sufficient size to hold a variable of that type, and a name is associated with that storage space. Assignment is the storage of a value into that named space, and I do so with the assignment operator, which is the equal sign. Now, declaration is accomplished by declaring the variable type and the name I wish to choose to refer to the space that's put aside. So my variable name is an alias for my storage space. So my declaration is the variable type, the variable name. Remember that the variable name is an alias for the storage space. So here's an example of declaring a variable. Here I declare a variable of type int, I name it A. Here I declare a variable of type double, I name it B. I can declare multiple variables on one line as long as they are of the same type. Here I declare three ints, A, B, and C. You'll note that those names are separated by a comma. Here I declare three doubles, D, E, and F. Now assignment is the placement of a value into that namespace, into a namespace. And I carry out assignment with the name of the variable, the assignment operator, and the value that I want stored into that space. Remember, that variable name is an alias for the storage space. When I store a value into a space, it must be of a type that's appropriate for that storage space. We look in the lecture notes and the lecture food chain at how Java will allow us to accommodate different types into different storage spaces, and we'll look at that in a while. So here's an example of assignment. Here I have a previously declared variable of type int named A, and here I'm storing the value 5 into it. Here a previously declared variable of type double named B, into it I'm storing 1.5. I can declare and assign on one line, and when I do this, it's typically called initializing a value. I do so with the variable type, the name of the variable, the assignment operator, and the value that I want stored in that named space. Remember, the name of the variable is an alias for the storage space. So here I have declaration and assignment. Declaration always on the left side, assignment on the right. Now I can declare and assign this way. I've declared an int named A, I've given a value of 5. Here I've declared a double, given a name of B, and given it a value of 1.5. I can have multiple declaration and assignments as long as they are of the same type. Here I've declared three ints, A, B, and C, and given them the values of 1, 2, and 3. Here I've declared three doubles, X, Y, and Z, given them the values of 1.5, 2.3, and 4.7. Here I would like to put into the spaces Q, R, and S the same value. I declare a value, a variable Q, a variable R, and S, all of type int. Here I put into those spaces the same value, 12. 12 is stored into S. What's in S is stored into R. What's in R is stored into Q. Evaluation always goes from the right to the left. So 12 stored into S, S into R, R into Q. Now, we know that a variable is something that we anticipate will or can. It might change, it might not. It can change. And with a variable, we always take what's on the right of the assignment operator and we store it into what's in the left of the assignment operator. What's on the right is called the right value or R value. On the left value or the left value. That value on the right is stored into the storage space that's aliased by the name that's on the left side. That assignment operator, the equal sign, takes what's on the right, stores it into what's in the left. Now evaluation always goes from right to left. We take the right value, we evaluate it, it's stored into the left value. This is all done by our compiler or as our program runs. So here we have a variable of type int named h. It's declared and then given a value of 4 plus 5. What happens is 4 and 5 are added, 9 is returned, that's stored into h. Here I overwrite the value in h. 7 minus 3, that's evaluated, 4 is returned, it's stored into the space h. There are different variable types. We've talked about primitives. There are also variables of class types. Primitives are called indecomposable. We can't break them down. Variables of class types are instances of classes. That's beyond the scope of what we want to talk about today. We're just going to talk about primitives. So, what are the primitive variables? They are booleans, chars, bytes, shorts, ints, longs, floats, and doubles. Boolean variables can hold true or false, those words, true or false. Chars can hold single characters, A, B, C, etc. Byte, I hold an integer, a whole number. Short, an integer. Ints, integers. Longs, integers. A float can hold a floating point number, a number with a decimal value. A double, the same, holds a floating point number. Now, each primitive variable has a specific number of bytes put aside to hold it and a range of information that it can hold. We know with a Boolean I can hold true or false. 1 byte is put aside to hold a Boolean. With a character, I can hold a single character from the Unicode. 2 bytes are put aside to hold it. With a byte, I can hold an integer, a whole number. 1 byte is put aside to hold a byte, and in it can be stored numbers from -128 to +127, whole numbers. In a short, I can hold an integer, whole number. 2 bytes are put aside, and I can hold a number from -32,768 to +32,767. In an int, I can hold a whole number. 4 bytes are put aside, and then a whole number can be in the range of -2,147,483,648 to 2,147,483,647 positive. Into a long, I can put integers. 8 bytes are put aside to hold longs, and in a long, I can store a number from 9 quintillion, 223 quadrillion, 372 trillion, 36 billion, 854,775,808 to +9 quintillion, 223 quadrillion, 372 trillion, 36 billion, 854,775,807. Into a float, I can put a floating point number, a number with a decimal value. 4 bytes are put aside for floats, and I can hold in it a number positive and negative, 3.40282347 times 10 raised to the 38th, which means I can move that decimal position 38 positions to the right. On the other end of the range of positive and negative, 1.40239846 times 10 raised to the -45th, which means I can move that decimal position 45 positions to the left. Into a space of type double, I can put a floating point number. 8 bytes are put aside for doubles, and in it I can put a number in the range plus or minus 1.797,693,1348,623,1570 times 10 raised to the positive 308th. 2. Positive or negative 4.9406564 584,12,46,544 times 10 raised to the negative 324th. Now, in Java we have what are called constant variables, which seems an oxymoron. They are variables that are assigned permanent values. They are more typically known as constants. They do not change. They cannot change. They must be initialized before they are used, and they cannot be modified after they are initialized. So here we have the declaration and assignment of a constant. I do so with the keyword final, the variable type, the name of the variable, the assignment operator, and the value that I want stored into that space. Here's a specific example. Final int speed limit equals 55. My keyword final, my variable type, my variable name, and the value that I want stored in that space. You note that the name of the variable is in uppercase. By convention, we have all names of constants in all uppercase letters. Now, I can accomplish in 2 lines what I did in 1. I can declare my constant with final, the variable type, and then the variable name, and then I can assign a value with my variable name equals value. Once established, once given a value, the variable, the constant, it can't change. If I were to declare a constant, public final int speed limit equals 55. Don't worry about the public for right now. Final int speed limit equals 55 establishes a constant named speed limit. I give it a value of 55. If I try to execute this line right here, speed limit equals 55, to give a new value to speed limit, I would be given an error at compile time. I would be told that that can't be done. So what have we looked at today? We've looked at declaring and assigning. We've looked at primitives. We've looked at how we accomplish working with variables, kinds of values, the memory space put aside, the size of the range of the values that can be put into those spaces. And we've looked at constant variables. Thank you very much.